Okay, folks, let's just recap what we did in the previous lesson. We're finding the equation of the tangent at -2, and we know that that is x1. So our x1 is equal to -2. How did we get y1? y1 was the f of -2. And you remember we worked it out at -8. That's what we did. You substituted back into the original, which gives you then the y value. So that's an important, and then what was the other thing that you needed? We needed the gradient of the tangent, which was the derivative at -2, which we worked out to be 18. So we've got critical values that we had there. And then when you plugged in, you had y minus y1 is equal to mx minus x1. Okay, and you were then able to work out the equation of the tangent there, which we did. Okay, so that was y plus 8 is 18x plus 36, and you could then easily get that, and you could solve, you could get for y is equal to 18x, and then 36, that would give you 28 there, okay? And that was the equation of the tangent, and that was an important principle that you needed, okay, to be able to do this. Now, something else, before we explore the next example, which is a typical matric exam question, I want to highlight a few little principles quickly for you. Okay, I want you to look at this thing here, and what I want you to notice is you've got a turning point. There are two turning points there. What do we know? Now, this is so important. If you look at the tangent there, we know, and in fact, at that point there, it could be -1, let's say. The derivative at -1 is 0. Whatever this turning point is, we could have worked it out, and we can call it A or anything that we like. The derivative at A is 0, because at a turning point, your gradient of your tangent is 0. Now, that is an extremely important principle. But, so to recap this, let's just have a look at this. If you've got a turning point, the gradient of the tangent is 0. So your derivative at whatever point is there, that could be A, I don't know what it is, okay, is 0. But also, there's a very important principle. The point itself lies on the graph. Okay, there's an X and a Y. If you go back here, if you look at this point, -1, 0, it lies, there's an X and a Y, it lies on the graph. But what's useful about this is we've not only have a point on the line where we've got X and Y, but we also have the gradient at that point being 0. Now, this is an extremely important principle. And remember, this is another thing that you need to remember if you have a look here. If you talk of f of -1, that's the y value, that is 0. The f of -1 is the y value corresponding to x. But the derivative is something else. The derivative, if you take this here, is 0. Okay, so you might have, whatever point you have, an x value. If you f the x value, the f of the x gives you the y. But the f prime, the derivative, is going to be the gradient of the tangent. Now, this leads into an extremely complicated example. And what I want to do is I'm just going to go through this quickly with you. Okay, what I'm going to do is I'm going to go through another example with you, and let's have a look at this. Now, this is really off an exam paper, and I want you to focus on this, especially you matrics that are going for good symbols. It's not difficult. It involves simultaneous equations, but there's a lot in here. Now, remember, now this is important. Please listen to me. When you're given a turning point, or a stationary point as they call it, what is important is the gradient of the tangent to the curve at that x value is 0, but the point also lies in. So if you look at this, it says this is a cubic graph here. It's got A, B, and C. We don't know what that is sketched below. The turning points of the graph are this. Okay, now what we could do, if I just draw a little picture here quickly, it's a sad one, so it would probably do something like this, okay, that cubic. Now remember, the little x value there is 2, and that's 5. Now, I don't know what the x-axis is, but you would see that that's 5 there, somewhere the x-axis. I don't know if it's cutting or whatever. I'm not worried about that. And then that'll be 2 there. Sorry, that's the small one, and that's 5. That's the big. That's where the maximum is. That's where the local minimum is. Now, the important thing about this, you have got, if I actually look at this, if I just take that, if I make that a little bit bigger, okay, at that point, you've got the point 2, -9. Now remember, this is the y value corresponding to x equals 2. And what do we know that -9 is? It's the f of 2. You substitute into the original equation. So if you worked out f2, it is actually 9. Do you see that there? But what's also very interesting is at the turning point, whether it's a minimum or a maximum, the gradient at 2 is 0. The gradient, the derivative at 2 is 0. The tangent line at that point has a 0 gradient. So there's 2 incredibly important principles here. Is this one, the f of 2 and the f prime of 2. Okay, so please, please, please focus. Now, what I'm going to do is I'm going to take you a little bit further. Okay, let's have a look. Here's the cubic. I've actually drawn it nice and accurate. They gave you the picture. Notice you've got a turning point. And what do we notice here? You've got a little tangent there. And what's the gradient of the tangent? Is 0. The derivative at 2 is 0. But the f of 2 is -9. That's important. And likewise here, the derivative at 5 is 0 because you've got a tangent, but the y value is 18 corresponding to that. So people, bear with me on this one. Those are 2 important principles we're going to use in the next part of this lesson. Stay with us. We're going to be back for some more wonderful calculus.